Hello everybody! This is the video I promised you about the 3D Constellations lab. It's going to be brief, but I wanted to show you a few little tricks that will make this lab really much easier for you. This is the 3D Constellations lab. The idea is we're going to look at constellations with depth perception. Let me show you more what I mean here. These are the instructions that come out of the lab. I'm just throwing them up here for a second for you to see. This is the link you're going to go to find the information about the constellations. It's the International Astronomical Union thing. You're going to be doing 3 constellations: Cygnus, Leo, the Big Dipper, which is in Ursa Major. If you have any trouble finding that, canvas me, message me, and I'll help you. You're going to need 3 sheets of graph paper. You'll do each of the following steps for each constellations. There's a link on the lab that'll let you print out graph paper that'll work very nicely. Now, when you get to this website, you scroll down to charts and tables, and when you get to the alphabetized list of constellations, you go down the list and find Cygnus, Leo, and the Big Dipper. I'm going to show you Gemini, just because it's an easy constellation, a straightforward thing to do. When you get there, click on the GIF, and it'll take you to a map of the constellation. It'll look just like this. This is an actual GIF of Gemini right out of that website, Gemini, and here's the constellation right here. It'll show you, it'll be highlighted like this. It'll have the bright stars with big dots and the dim stars with small dots. It'll have proper names. It'll also use the Greek alphabet here: alpha, beta, gamma, delta, epsilon. And we're going to choose, I'm going to choose these 2, and I'm going to do, this is the twins, okay? So I'm going to choose a couple down here, and I'm going to choose delta and epsilon here, just because they're bright and yet they sort of outline the constellation. You don't have to do many more than that. You could if you wanted to, but you don't have to. 6 should be enough. Don't just choose 2, because that'll be boring. You won't see very much that way. So what we do then is we reproduce the look of this constellation onto your graph paper, and I'm going to show you exactly how to do that. Here's the instructions, then I'll show you how to do it on the graph paper. Based on the INU map, make a sketch of the positions of 6 to 7 brightest stars in the constellation. The line that you're drawing, I'm going to show you right now. Label each star with its name in Greek letter if it has no proper name. So here we go. This is the last chart in this presentation. So it's all here. This is what your sheet will look like when you get done. At the top, it'll have your name. It'll have your constellation. Remember, you're going to do 3 of these because you're going to have 3 constellations. And one of them will not be Gemini, so it won't look like this. Then over here, put Lab 2 on all 3. And here we have them. There's the 1, 2, 3, 4, 5, 6 stars I chose with their names: Castor Pollux, Mu, this is Gamma, Alhena. Some of them have proper names and Greek letters. And then we go search Google for the star names. Believe it or not, almost every medium to bright star name is in Google with complete information. You'll be amazed. If you look up Castor, you should probably use Castor star as the keywords. That way you'll get there for sure. If you look up Delta, there is no name here, so you look up Delta, D-E-L-T-A, and Gemini, Delta Gemini star. Search that, you will find this puppy right here. This is the only one without an actual name. Alhena, oh, I'm sorry, Mu has no actual name either. Mu is simply M-U, Delta is D-E-L-T-A. This one is Epsilon, but you can also use Mebsuba for the actual name. It'll be there, Mebsuda Gemini star. And you will find that puppy, friends. Now, what you do is you look up the distance of each of the stars in light years, and you write it down just like I've done here, right by the star. And notice we were talking about the horizontal line. I'm going to have you draw a horizontal line. Let's see, 1, 2, 3, 4 major squares from the top, and go right across like this. This is the area we're going to use to plot the stars. This is what you see in the sky. And this is the area we're going to use to plot the distances, the 3rd dimension in this whole thing. See, it says distances right there. This is the 0 point. This is where Earth is. And we're looking out farther and farther at these distances. Now, the next step is simple. You just look for the most distant star. And it happens to be Mabsuta at 840 light years, excuse me. And so we automatically put that at the bottom because we want all the stars to plot here somewhere. And if we take the most distant one and put it at the bottom, we'll get them all on the same sheet. But now we need a scale factor to know where to plot these things on this sheet. We know their real distances, we just don't know where they appear on this sheet. So you measure the distance from the horizontal line, which is 0, down to the bottom, which is just scanned off here. I'm sorry about that. And that'll be, well, I measured it to be 5.6 inches, but you should measure it yourself because it may be different in your sheet. And that's the actual page distance. And we know that the actual distance for stars is 0 to 840. So 5.6 divided by 840 is your scale factor, and that turns out to be 0.007. That's your scale factor, 0.007 inches on the sheet per light year in the sky. So that's a magic number. Using this number, we take the scale factor and multiply it by all the distances in light years, and it tells us where all of these stars plot. And that's how I knew where to plot these things. For example, delta is 61 light years, we multiply it by 0.007, and it comes down just short of a ½ an inch. And so you're going to need a ruler to actually plot this because you're going to be measuring those distances. We know where to plot Mabsuta because that was the one we stuck at the bottom in the beginning. Notice that 230 mu, well, all we have to do is multiply 230 by 0.007, and it comes down here about 1.8 inches, give or take. And so that's how I knew where to plot all these things. And now that we've plotted them, the question is, what are we looking for? Well, we're looking to see if the stars are all at the same distance because they're in the same constellation. And it turns out you can see it very obviously here. These stars are not even in the same county, friends. They are totally out of it. For example, these two stars don't even know each other exist. They're more than 100 light years separated. Castor and Delta are kind of close distances, but they're not in the same direction. So it's not likely they're interacting. Pollux and Castor are separated by 23 light years. Now, one way to think about this is what's the distance to the nearest star in the sky for us? That'd be about 4 light years. 4 times 6 is 24. So the distance between Castor and Pollux is about 6 times the distance from us to the nearest star. Okay, and that suggests that Castor and Pollux are not interacting at all either. So what we've shown here is that these stars are all far apart. They don't even know each other exists. And that's what you should write here in your own handwriting just across the chart, saying stars are separated, are not interacting, however you want to put it. And then declare victory because you have been victorious. And you do it again for your second constellation, and do it again for your third constellation, and then follow the instructions in the lab to the letter, and you will be a cosmic winner. Okay? We'll see you soon.